Welcome to this explainer. Today, we're talking about electricity, that invisible river of energy that literally powers our entire lives. But here's the thing, when it escapes its intended path, it becomes a totally silent, lightning-fast predator. We are going to break down the actual science of a shock, what physically happens beneath your skin, and the safeguards you absolutely need to know. Let's get right into it.
Okay, so let's kick things off with a pretty serious question. Is the place you sleep, the place you literally raise your family, secretly wired for danger? I mean, we put a massive amount of trust in the walls of our homes, right? But that trust can kind of breed complacency. We flip a switch 100 times a day without a second thought, completely forgetting the immense power humming just millimeters behind the drywall.
And honestly, the stats reflect that. Get this, there are over 30,000 electrical injuries in the US every single year. Let that sink in for a second. That is tens of thousands of incidents proving our everyday convenience definitely comes with some hidden risks. And the craziest part? The vast majority of these are entirely preventable if we just understand a little bit more about the forces we're dealing with.
Which brings us to Section 1, the anatomy of a shock.
First up, we need to clear up some terminology, because people mix these up all the time. Medically speaking, they are very different. So, an electric shock simply means you accidentally became part of the circuit and current passed through your tissues. Electrocution, on the other hand, is a very specific, grim term. It strictly means the event was fatal or caused severe, life-altering trauma. So, if you touched a wire, felt a nasty zap, and walked away, you were shocked, not electrocuted.
Now, if you really want to picture how a shock harms you, just think of electricity like a rushing river. Voltage, that's the speed of the water. It's the pressure pushing everything forward. Amperage is the actual heavy volume of water crashing into you. It's really the combination of that high-speed pressure and the sheer volume of current that determines how lethal a shock actually is.
And we also have to look at the type of current flowing through that river. Surprisingly, your home's alternating current, or AC, is actually way more dangerous than the direct current, the DC, sitting in your car battery. Why? Well, because AC frequencies force your muscles to flex uncontrollably. It's a state called tetany, and it's terrifying because it physically locks your hand onto the source of the electricity. You're completely aware, but your muscles literally refuse the command to let go.
So what happens next? Let's look at Section 2. What happens inside you?
You know, the true damage of a shock usually isn't what you see on the surface. We really have to look at what happens when current breaks past your skin. Nature gave us a pretty great shield. Dry human skin can resist up to 100,000 ohms. But just look at how quickly those numbers tank. The higher the voltage, the faster your body's resistance just completely breaks down. A high-voltage shock punches right through that skin defense, dropping your resistance to just hundreds of ohms, and letting all that current flood straight into your highly conductive internal tissues. And once it's inside, the damage is just visceral. Electricity is lazy. It takes the path of least resistance, which means your blood vessels and nerves. It completely disrupts the heart's delicate rhythm, causing ventricular fibrillation. And it's crazy, but recent medical reviews show it also severely damages the liver, causing blood clots, and even pushing air bubbles into the biliary tree. It literally cooks your skeletal muscles from the inside out, sometimes even rupturing tendons. And as those muscles break down, they flood your bloodstream with dead tissue, totally overloading your kidneys and triggering renal failure. It is incredibly serious stuff.
Knowing all this, we need to locate the risks. Section 3. Hidden hazards at home.
Awareness is absolutely our best defense here. These 6 hazards are the most common culprits for home electrical injuries. We're talking basic stuff like missing or broken outlet cover plates exposing live wires, or a lack of GFCIs near water sources in the kitchen. Also, have you ever unplugged a vacuum while it was still running? Yeah, don't do that. It can create an invisible arc of electricity jumping right from the outlet to the plug. Add in uncovered outlets near kids, frayed cords your dog chewed on, and the ultimate trap, unpermitted amateur DIY electrical work.
But hey, it's not all doom and gloom. Let's look at Section 4, your built-in home defenders.
The good news is modern engineering has brilliant ways to keep these electrical rivers in check. Now, they might look similar, but AFCIs and GFCIs do totally different jobs. AFCIs, or arc fault circuit interrupters, monitor the hidden wiring inside your walls for weird heat and arc patterns to stop house fires before they even start. GFCIs, ground fault circuit interrupters, act more like a personal shield. They watch the circuit for leaked current and instantly cut the power, especially near water, to prevent a lethal shock to your actual body. But because they both monitor the same lines, a super common misconception always pops up. People constantly ask, do they cancel each other out? There's this weird myth floating around that putting both of these devices on the exact same circuit will somehow make them interfere with each other, causing false trips or just ruining their safety features.
Let me tell you, the answer is a massive no. In fact, using combination AFCI and GFCI, dual-function breakers is highly recommended and honestly mostly required by modern building codes right now. They definitely don't cancel each other out. One watches for fire, the other watches for human safety. Having both on a single circuit gives you comprehensive protection, which is absolutely crucial in high-risk, damp places like your kitchen or laundry room.
Okay, let's talk about what to do in an emergency. Section 5. First aid and survival.
If the absolute worst happens, knowing how to react in those first few critical seconds is literally life or death. If you witness a shock, your immediate human instinct is going to be to grab the person and pull them away. Do not do this. Never grab them directly, or you just become part of the circuit yourself. Instead, your first move is to cut the power at the breaker. If you can't reach it, sever their physical connection using a dry, non-conductive object. Think a wooden broom handle or a plastic PVC pipe. Only after they are completely separated from the current do you call 911 and start CPR if there's no pulse.
And here is a fact I cannot stress enough. Remember how we talked about electricity viciously attacking internal organs? Because of that, internal injuries are almost always completely hidden. You must, absolutely must, seek professional medical attention within 48 hours of any significant shock, even if you feel totally fine and there's not a single burn mark on your skin. Your liver, your heart, your kidneys, they could be silently sustaining damage that needs immediate help.
So, now that you know the whole story, the invisible journey of an electric shock, what it does to the body, and the incredible tech designed to stop it, I'm going to leave you with a question. When was the absolute last time you walked around your house, pressed those little test buttons, and actually made sure your life-saving GFCIs are working? Seriously, take 5 minutes today and do it. Your safety is entirely in your hands. Thanks for hanging out with me for this explainer. Stay curious, and please stay safe out there.